Okay, so this is what you're working on. So make sure you have this sheet. Okay, we're going to take a couple of notes before you go back to your labs because some of y'all are a little confused on your lab. So let's look at the graduated cylinder first. Okay, you have one. I'm going to go ahead and draw one real quick. You're going to your stations and you are looking at some graduated cylinders. Okay, so when you're looking at them, you're reading what's called the before and the after. Okay, so the before could be, go ahead and color in orange at the bottom. Okay, orange at the bottom, we'll just call it, we'll call it water. And label it water. Okay? Then we're going to go to, we'll put in, just pick a color. It doesn't matter what color. And then I'm going to just choose pink. Okay, so this one we're going to call it corn oil. Okay? And then we're going to go up one more. I'm just going to pick yellow and we're going to call it rubbing alcohol. Remember when I did the activity with rubbing alcohol?
Yes.
Okay, and the rubbing alcohol, remember the ice sunk?
Yeah.
Yeah? Okay, so the ice sunk because it is more dense. Okay, it's more dense. And density is the calculation. You have to remember that. Density isn't just because it's heavier. A lot of things that are heavier are more dense. But that's not in reality what density is. It does match it occasionally, but it's always a calculation. Okay? I know. A lot of y'all think just because it's heavier, it's more dense. Remember the bowling balls?
Oh, yeah.
And the bowling balls, they had 2 8-pound bowling balls, one sunk and one didn't, because it has to do with the material that the bowling balls were made of. The material, one of them, the material was more dense, the other one, the material was less dense. Okay, so this is going to be rubbing alcohol. Okay, so you should have these 3 things on your graduated cylinder on this paper here. Okay, so you're coloring in 3 things: water, corn oil, and rubbing alcohol. This is density. I'll lay this right here. Okay, so this one here, this is most dense. The rubbing alcohol is least dense. The corn oil is just in between. So the water is going to be, I'm going to write it right here. I ran out of room. Most dense, and this is least dense. That's density. When you're going to your stations, you have to find the mass of it, and you have to find the volume of the object. Okay? Let's go to where it says define it on your paper. To the right. Right here to the right, let's go to define it. Okay? Density, like I said, when I go to Florida, I'm going to pack a bigger suitcase because the last time I had a smaller suitcase, I literally was dragging that thing. My back was breaking because I was lugging all my stuff where I was going because I made it too dense. If I get the rolling suitcase and I spread out the same amount of material, it'll make it less dense. So the more closely packed things are, the more dense it is. The more it's spread out, the less dense it is. So the molecules in rubbing alcohol are spread out more. Okay, let's do the definition and we'll go to what I was just thinking of. Okay, so your definition is, it's a measurement. Okay, it's a measurement of how much mass, that's why you have to find the mass, of a substance contained in a given volume. That's the definition. It's a measurement. And a lot of times your measurement is the same thing as what you're thinking. But I mean, I realized when I was, I went to, I forgot where I went. I think it was Louisville, when I had Louisville, the race last year. I jam-packed that bag so heavy, I was breaking my neck to carry it. Woo! And I was so mad at myself for it, because all I had to do was get a bigger suitcase and spread the same amount of material, and it would be less dense. So this time when I go to Florida, I plan on making my suitcase less dense, because I don't want to break my back. Okay? So if you pack more mass into the same volume, it's more dense. If you pack the same mass into a smaller volume, it's more dense. So if you pack more mass into the same volume, it's more dense. If you pack more mass into a smaller volume, it's more dense. So density has to do with how much you're going to pack together. That's the amount of matter. It's packing together. Okay, so let's go to your molecules, what your molecules look like. This is more dense. This is more dense. This is what it looks like. This is what my suitcase looked like. That tri-bag, my Ojo bag, was more dense. This is less dense. So if I take the same amount of material and I put it in a bigger volume, it'll be less dense. If I take this material here and I put it into a smaller volume, I'm making it more dense. Does that make sense?
Yeah.
Okay. Because you want to spread your stuff out and make it less dense when you go packing. That's why when you go grocery shopping, I'm really bad about it. I just cram everything in one bag because I don't feel like carrying 45 bags. I make everything so dense that I end up ripping the bags. Because I'm lazy. I don't want to walk back and forth 25 times. Well, yeah, okay, it's lazy. I don't want to walk back 25 times up and down the stairs to go take stuff. So I cram it all, make it as dense as possible, and I lug it up the stairs. It's my choice, but well, I hurt myself half the time. That's just what it is. Okay, and so principles of density. That's on the right-hand side of your paper. Make sure you fill out your circles. Don't forget, this goes in the circles. Those boxes, this is more dense. This is less dense. That goes in your boxes. Where it says, drawing the molecules. Mine's already done. Less dense, more dense. Make sure you draw them. Have you drawn them?
Yes.
Okay. Now we're going to go to principles of density. I love the principles of density. Density is, I find it unusual. I like it. I think it's cool. Okay, so if the mass is larger, I'm teaching you a shortcut. If the mass is larger than the volume, the object will sink. Just leave it. Just leave it. Guys, just leave it. Just leave it. If the mass is larger than the volume, the object sinks. If the mass is larger than the volume, the object sinks. Write that down. If the mass is larger than the volume, the object sinks. Okay?
I didn't say you could turn it all the way off.
Well, y'all didn't turn it off.
He needs to power it. I can turn it off.
It's out here now. I can't take it anymore. Okay, so if the mass is larger than the volume, the object is going to sink. So when you go to your measurement and the mass, and you see the mass is bigger than the volume, you know it's going to sink in water. And water is 1 gram per milliliter. Okay, remember water. 1 gram per milliliter is the density of water. So if the mass is greater than the volume, it's going to sink. Now here's another shortcut. If the volume, I'll speak loud, if the volume is larger than the mass, the object floats. Write that down. The object is going to float. These are two shortcuts that are really, really good shortcuts to know if it's going to sink or float in water and to understand density. So if the mass is larger than the volume, the object is going to sink. So you find the mass on a triple beam balance or balance scale. And then the volume, remember you have to use the two graduated cylinders to find the volume. The displacement method. You remember you're doing that today. You go and you read the before, and then you read the after. Then what do you do to get it? How do you calculate? Subtract. Yes, you subtract. So you would have the first one, you would read it, then you would have the second one, then you would subtract the two. Okay, so if the volume is larger than the mass of the object, it's going to float. Do you have that down?
Yes.
Okay, good. And then write down your, how do you calculate it? Raise your hand. Raise your hand. I want to hear a hand raise. I want to hear your hand raise. I want to see your hand raise. Ricky.
Subtracting the before and after.
No? How do you calculate density? Sorry, I didn't make myself clear. How do you calculate density? Look at the poster. Look at the poster. Look at the poster. Dakota. Mass divided by volume. So on your paper where that box is, put your heart. Or however you want to write it. I ran out of colors. I have to use ugly brown. Mass divided by volume. That's how you calculate it. And it doesn't matter how big or how small the number is. You do mass divided by volume. It could be 15 divided by 25. Don't fix it the normal math way. You're going to do math a little odd. It's always mass divided by volume, and it could be a problem that looks like that. So that is why I want you to use a calculator. Use a calculator. Okay?
No, 15 divided by 25.
It's still going. Okay, good. All right. Yes.
So is the stuff that doesn't have water in it volume or mass?
Say that again.
Shh. In the this thing, like, is the empty stuff, or is it the mass or the volume?
I don't understand what you're saying. Is the empty stuff?
Like that's part that's not filled up with water.
For what?
When you divide it.
To calculate density?
Yes.
Okay. First thing you're going to do when you go to your stations, you're going to have two graduated cylinders. Those look pretty bad. No, we'll deal with it later. It's driving me nuts too. Okay, I know it's bugging me too, but whatever. Okay, so here is the before. Here is the after. Okay? Here is the object in the after. Okay? This is called displacement. You can't find the volume. Let me make the object a little, no, there we go. Okay, this is volume. So you're trying to find the volume of this object right here. Okay, using the displacement method. So the measurement before, let's say this is 20 milliliters, and let's say that's 40. So you're going to go to your stations, and you're going to be looking at a virtual paper copy thing. Okay? You're going to do this. So you're going to subtract 40 minus 20, and you get 20 milliliters. That is going to be your volume of that object. Density is mass divided by volume. So now you know the volume is 20 milliliters. Okay? You're going to look at a triple beam balance. And this is really bad, but, you know, whatever. Well, that's about as good as I can draw that thing. Okay, so let's say that is on there. Read the bars. Okay, remember I told you to circle the numbers. Let's pretend that beautiful little drawing there. Let's pretend this number is 13 grams. Okay, so now the mass is 13 grams. Density is mass divided by volume.
13 divided by 20.
Yes. 13 divided by 20. And that is going to be your density.
It's gonna be 0.
That will be the density of this answer right here.
It's gonna be 0 point
So the
something.
density is 0.
You see what I'm saying? Okay, so when you go to your stations, you're going to, first of all, look at the mass. So you're going to look at the triple beam balance. Then second, you're going to do the before, you're going to do the after, then you're going to do the volume. Then where it says calculate it, you're going to calculate it. And this is the calculation. Okay, and then on the lab, it's telling you to, you're trying to match it with an object that's on the back side of your lab sheet. Thumbs up if you're okay.
Yes.
And if you have a thumbs down, you're going to come see me. And if you have a thumb sideways, you're going to come see me. All right, go to work.